Okay, so to begin with, on this section, we're going to introduce ourselves to quadratic functions. And first thing you need to know is what a quadratic function structure looks like. So it has the structure ax to the second plus bx plus c. So you'll see quadratic functions kind of looking like this, for instance, maybe 2x to the second minus 3x plus 4. Okay, now you have to have the x squared, but you don't have to have these other two numbers. So you could just have f of x equals x squared. You have to have the x squared, but the other two positions here you don't have to make it quadratic, because this thing could be written like this. Okay, so you got to know what we mean by quadratic function. A, B, and C can be any number. And we'll kind of look at some basic things here. I'll talk about what this diagram means here in just a minute. So a parabola is the name that we use for a quadratic function, and it can open up or down. So this would be what the graph of a quadratic function looks like. So in this particular example, these two things here would be the x-intercepts. Now, I'm going to just have to estimate what they are. This looks to me like it's somewhere between 2 and 3, so I'm just going to say 2.70. Okay, the thing that you want to know, again, is that when you have an x-intercept, y is 0, because you're not moving up or down, you're on the axis. Okay, this point over here, we could say that looks to me like maybe it's negative 0.7 and 0. Okay, I'm just estimating that. Okay, and again, the y value is equal to 0. Okay, now the y-intercept would be this point right here. Okay, and it goes like this. Anytime you have a y-intercept, x is 0. So it looks like that y value is down 2. So it looks like that y-intercept would be 0, negative 2. Okay, the vertex is this point. Okay, that's the point where it comes together. It's symmetrical about that vertex. That's either the low point or the high point, like it would be on this. So this vertex would be the point. It looks like has an x value of negative 1, and it has a y value of negative 3. Okay, and this one is opening up. Okay, so the parabola is opening upwards, so it's going to infinity like that. Okay, all right. So what I want you to do is just look at this next diagram and just kind of quickly fill out this second one. All right, so just check and see if you got this right. The x-intercepts are estimated, so hopefully you're close to this. What I wrote on this one was negative 0.8. I mean, that's negative 0.5 right there. Then I put 1 to negative 3.2. If you don't quite have that, that's okay, right? So the y-intercept is this point right here, which is the point 0, negative 5, so that's down 5. And then this is the vertex, so it has an x value of negative 2, y value of 3, and I have no idea why I did this. Okay, that's opening down, okay, like that. So that's what you should have, all right? So one of the things I want to show you as we go through this, we're going to look at some properties of parabolas next. And what I'll look at here is this is a quadratic function structure again. So it's going to open. It all depends on what this number is here. If a is bigger than 0, then it opens up. So an example would be something like f of x equals 2x squared minus 3x plus c. And it's just because this number that I'm highlighting, that's bigger than 0. So that makes the graph of this parabola open upward. Okay, it's going to open downward if a is a negative number. So an example of this would be something like negative 3x to the second plus 2x minus 5. It doesn't really matter what the last two terms are. The only thing that matters is what that term is. And since that is less than 0, that's what's going to cause the quadratic functions graph to go upside down. All it is it's a reflection, like we've learned. Okay, this is real important to write this down. So if you're going to find the x value of the vertex, you do negative b over 2a. And again, that comes from your quadratic. You have a and b here, So if you do the negative what b is divided by 2a, you get that. And then the domain of any quadratic function is always all real numbers. So you can write it that way, or you can write it this way. Not like that. So you can say set of x, and you can just say x is a real number. Okay, so it can be written either way. The domain's always everything, because you can take any number and square it. There's no number you can think of that you can't square. There's no number you can't multiply by another number, so everything works. And if you want to find an x-intercept, you set f of x equal to 0. And if you want to find a y-intercept, you let x equal 0. And the reason for that is, again, is because anytime you have a y-intercept, it's the x value that's 0. So you don't want to memorize this stuff. You want to understand it. If you understand it, of course, it'll stick with you. The reasoning behind this other thing would be like this. Okay, that's an x-intercept. That's the x-intercept to 0. So the function value is what's equal to 0. Okay, so it's the y value or the function value that's 0. Okay, next page. Go ahead and just do these. Pause the video, if you would, and then just check yourself on these. Okay, so go ahead and see if you got what I got. The vertex is the point I have in yellow. That's 1, -4. Parabola opens up. X-intercepts are the 2 points I have highlighted in blue. One of them is -1, 0. The other one's 3, 0. Y-intercept is the point in green, 0, -3. Okay, over here on this example, vertex is the high point. Parabola opens down. The vertex is 2, 1. X-intercepts are 1, 0, and 3, 0. Y-intercept is 0, -3. All right, so you want to know those key parts of a parabola. Now what we're going to do is I'm going to give a function. We're going to graph it and put it all together based on being given the graph. Okay, so first of all, one thing we want to kind of do on this is when we look at this, we have this is the number in front of x, b is that number, and c is that number. So you would have a as 1, you would have b as -2, and you would have c as -8. So you want to know that. So this thing is going to open up because a is bigger than 0. Okay, so that's the first thing you want to know, is we know this parabola is going to open up just by looking at it. Okay, when we do the vertex, there's 2 parts. Part 1, we want to do -b over 2a. Okay, so we go ahead and do that. B is -2, so you would say -2 over 2 times a is 1. Now see, what we're doing is we're finding the x value of the vertex. So if you work that out, that would be 2 over 2, so that would be 1. So what you're doing is you're finding the x value of the vertex by doing -b, the negative of what b is, over 2a. All right? The second part of this is just evaluate the function at 1. So take your function, everywhere you see x, plug in a 1. So you'd have 1 to the second minus 2 times 1 minus 8. So that's 1 minus 2 minus 8. That's -9. So that would end up giving you your vertex then. Okay, so as we put this together, we just need to plot this point. So I'm going to go over 1, down 9, and label that as our vertex. All right, now this parabola opens upwards, so another thing you can do, you don't have to do this, but we call this the axis of symmetry. And the axis of symmetry, what that is that's a vertical line that just divides the parabola in half, okay? All right, now let's go down, let's do the x-intercept. So what you do for an x-intercept is you set the function equal to 0. So you take the function I gave you and you solve the equation 0 equals x the second minus 2x minus 8. All right, so what will happen is these things usually factor. They don't have to. If they don't factor, you got to use what's called the quadratic formula. Now this one factors. So it goes like this. The first term is x, and I think a lot of students in this class have to review factoring because they've never learned it real good or they've forgotten it. So when you look at factoring, this is the way you ought to look at it. It's like this. This is the result of the first term. So x times x is x squared. That's the easy part. This is the result of the last term. Okay, so what goes here is the result of the last term. In this case, there's two possibilities. There's 1 times 8, and there's 2 times 4. This one is the result of the outer and inner added together. So if you're going to add these numbers together, you're going to use 2 and 4 because you can make 2 and 4 add to -2. So what I do is I put a 2 and a 4, and it doesn't matter what order. Then you got to figure out the signs. So the inner term would be 2x. The outer term would multiply to give 4x. You're wanting those to add to that middle term, which is -2x. Okay, so if you want this to add up to -2x, it means the signs have to go +2 minus 4. Okay, so you have a plus there and you have a minus there. So anytime you factor something, you want to make sure you multiply it out. Don't move on. Make sure it's right. You got the ability to do that by foiling it and multiplying it out. So then we just solve the equation x plus 2 equals 0, which you can do in your head, and x minus 4 equals 0, you can do in your head. So solve that. That gives x equals -2. So one of your intercepts is -2, 0. The other one, add 4 or do it in your head. That gives x equals 4. So that would be your 2x intercepts. All right, so what I'll do now is I'll just go to -2, 0, put a dot, 4, 0, put a dot. Okay, so we're trying to get as many points as we can. All right, then the next thing we're going to do is a y-intercept. You set x equal to 0. So if you go to the quadratic, which is f of x equals x to the second minus 2x minus 8, what you do is you do f of 0. So that is 0 to the second minus 2 times 0 minus 8. So that's equal to -8. So you end up getting the point 0, -8. Okay, and then what we'll do is we'll plot this point, and then we've got enough points to make a very accurate graph. And then I want to show you something that happens on a parabola. Okay, now this is only if you have 1x squared, then what you can do, if this number is not 1, it doesn't work. But if that's a 1, like we have here, you can go over, this is your vertex. You can go over 1, up 1, or you can go over 2, up 2 to the second, which is 4, or you can go over 3 and up 3 to the second, which is 9. You're doing a squaring function, so it's nice to know this stuff. So what I'm going to do is go to the vertex. I'm going to go over 1, up 1, put a dot. Go back to the vertex, go over 2, up 2 to the second, which is 4. So over 2, 1, 2, 3, 4. Where's your dot? Okay, 1, 2, 3, 4. Or you can go over 3 from the vertex, 1, 2, 3, and up 3 to the second, or 9. So 1, 2, 3, 4, 5, 6, 7, 8, 9. Okay, you can do this backwards too. Left 1, up 1. Left 2, up 4. Left 3, up 9. And you could repeat that as far as you want to. If you go over 4, then you would go up 4 to the second. Okay, so that's just something that's kind of nice to know. Then what you do is just connect your dots, make sure you have double arrows. That's what the graph looks like. Okay, and again, what this is it's a picture. A graph is a picture of solutions of that quadratic. These are all the points. Every point on that quadratic, if you plug it into the formula, then it'll check. So it's a picture. Okay. All right, I'm going to do one more of these, and then I'm going to have you just do one of these yourself. Okay, so on the next page, again, what we have here is A is that number, B is that number, C would be 0 in this case. So in this problem, A would be 1, B would be 5, and C would be 0. Okay, so a couple things we know. First of all, this is going to open up because A is positive. So we know the graph is going to go like that. Okay, now we need to find the vertex. There's generally 2 steps in doing that. Step 1 is do the x value of the vertex is negative b over 2a. So b is 5, so it would be negative 5 over 2 times 1. So it's negative 5/2. Okay, and don't freak out because it's a fraction. That doesn't make a bit of difference. It's okay. It's normal if it's a fraction. Okay, and you could use, if you wanted to change that to negative 2.5, you certainly could. Okay, so what I'm going to do now, and you can do this with the help of your calculator, you do, the second thing you do is evaluate the function at negative 5/2. So you're going to do negative 5/2 to the second plus 5 times negative 5/2. That's equal to 25 over 4 minus 5 over 2. So get a common denominator, which is 4. So multiply by 2 over 2. Okay, make the denominators the same. So it's 25 over 4 minus 10 over 4, which is positive 15 over 4. All right, so that means that you get 15 over 4. Whoop. And again, you can change that to a decimal if you want to. So that would just write that as 15 over 4. And I'm going to show you how you can check this problem on the graphing calculator here in just a second too, because it's worth being able to do that. So if you notice what I just did, I mean, you could do this. You could go parentheses negative 5 over 2 to the second, and then plus negative 5 over 2. Oh, crap. That gives a decimal. And then you can go math, fraction, enter. And see, that changes it to 15 over 4 anyway. So what you end up getting is this is your vertex. And again, that vertex could be written as negative 2.5, comma 3.75. And that could help you to graph that then. So what I'm going to do is I'm going to estimate that and where it is. So I'm going to go left 2.5 in there and then up about 3.75. Just estimate it, and that'll be good enough. And the parabola is going to open upwards. Okay, so next thing that happens is we do the X-Intercept. So what you do is you set the function equal to 0. So you do 0 equals x to the second plus 5x. Okay, so you got to go through and then you got to factor that down. Okay. Oops, I think I put the wrong thing. No, I'm okay. Yeah, I knew I did something wrong because I caught myself. I didn't do this right. So let's get this corrected. I goofed up kind of bad on this, so I'll show you. But I knew that, and because I knew, here's what I knew. The parabola is going to open upward, and I can tell we're going to have X-intercept. So if it opened upward from there, it would never cross the x-axis. That's kind of how I caught my mistake. The more you know about math, the better you can catch mistakes. So what I didn't do right is this is 5 times negative 5 over 2. Okay, so what I'd have is square that. That would be 25 over 4 because you're just doing negative 5/2 times negative 5/2. Okay, multiply fractions straight across, so you get that. And then this would be minus, so you can put the 5 over 1, that would be minus 25 over 2. Get a common denominator now by multiplying by 2 over 2, and you're going to get 25 over 4 minus 50 over 4, which is negative 25 over 4. Okay, so that would actually be the vertex then. Now, what I'd suggest you do on this, I mean, you want to use technology. You want to know how to do stuff by hand, but you also want to be able to check and verify what you do. Gosh, you got technology, take advantage of it. So if you were to put it in, you'd go like this. parentheses negative 5 over 2. Whoops. Dang it. Parentheses negative 5 over 2. And let's see, square it. And then plus 5 times negative 5 over 2. Okay, that gives you negative 6.25. So if I went math, convert to fraction, that gives you the negative 25 over 4. So we now know we got that right. So your vertex is actually negative 2.5 and negative 6.25, which is much better. Okay, so go ahead and plot that. So we go left 2.5, down about 6.25. So just kind of estimate that. Crap, it's so hard to get that thing on there sometimes. And then you can do your axis of symmetry like that. Okay, and the parabola is going to open upwards, so you know it's going to cross the x and y axis. Okay, so now down here, we're going to find the x-intercept, set equal to 0. You factor this by factoring an x out. There's a common factor, so x times x is x the second, and then x times 5 is 5x. So you've got two factors. You set x equal to 0, so that would be one of your intercepts. And then you set x plus 5 equals 0, so you can subtract 5 from both sides. That would give x equals negative 5. Okay, so it goes like this. Okay, remember that when you do an x-intercept, it just means y is 0. Okay, so those would be your two intercepts. So I'll go ahead and plot those. So we have 0, 0, and we have negative 5, 0, like that. Okay, and that's also a y-intercept, by the way. So if you cross at the origin, it's also a y-intercept. So the way you find a y-intercept is you set x equal to 0. So you just do f of 0, which would be 0 to the second plus 5 times 0, plugging in the function, so that gives 0. Okay, so we got that. And this is good enough. I mean, all you got to do is just kind of plot this in, connect the dots like that. Be sure you do your double arrow, and that's what your graph looks like. So all of this stuff can be checked and verified. I want to show you how to do that. You don't want to just learn how to graph by just pressing buttons on your calculator, because you don't really understand concepts as good that way. So just go y equals, put in x to the second, and plus 5x. Okay, standard window, you can go zoom 6, and it's got everything you need. Now, see, you can trace at these points if you want to. So if you trace at negative 5 over 2, that was the x value of the vertex. Look what happens. You can tell that that's the correct vertex. Okay, you can trace at your intercepts too. You could say trace 0. There's your point 0, 0. You can trace at negative 5. There's your other x-intercept. So see, it's all easily verifiable on your graphing calculator. Okay, so pause the tape and do this problem, come back and check, and that'll be the end of part 1. Okay, so you want to go ahead and check everything that you did here and see if you're on the right track. Okay, so I've got vertex 4, negative 4, opens up, x-intercept 6, 0, and 2, 0, y-intercept 0, 12. So you can look over how I did that if you need to and correct yourself. Again, in this problem, a is 1, b is negative 8, c is 12. Since a is greater than 1, not greater than 1, greater than 0, that's why it opens up. Vertex, do negative b over 2a, so that would be negative 8 over 2 times 1, so that's 4. Evaluate at 4, so that'd be 4 squared minus 8 times 4 plus 12. That gives negative 4. So that's how you find the vertex. When you put this in the graphing calculator, you go to y equals and put it in like that. If you want to check your answer, you can go trace 4. Okay, we got x is 4 for the vertex, so you can tell that's right. X-intercepts, you got to be able to factor to do this. This is a lot of times I'm concerned that students don't factor very well in this class, so you got to practice that. So this factors as x minus 6, x minus 2. Therefore, you get 6 and 2 as your intercepts. Again, you can trace. If you trace at 6, you got 6, 0. If you trace at 2, you get 2, 0. So you know you're right. Okay, Y-intercept, you set x equals 0, so you get 12. I just went up a couple of notches to put that. Again, you can trace at 0 to verify that Y-intercept at 12. So that's it. Okay. The other thing you could have done, you don't have to do this necessarily, but again, if anytime you have a 1x squared, and this is only if you have a 1x squared, then you can go over 1 up 1, over 2 up 4, over 3 up 9, if you need to, over 4 up 16. You're going up the squares, so you could go over 1 up 1 to get that point, left 1 up 1 to get that point, just for greater accuracy if you want to. All right, so that'll close off this video then. So hopefully that'll help you get started.